Swayam Prabha. Digital India. Educated India.
Good morning everybody and welcome again to our course on Introduction to Mechanical Micromachining. So today we are going to discuss about the diamond turning process. What we are discussing here, that till now we have seen that we have discussed about the micromachining processes, and where we have seen that the size of the component is micro scale, or sometimes it is a big scale, but we are doing some micromachining at a smaller scale on the surface of a big component. Now, today's topic is little bit different than the micromachining. What we are doing here, that our component size may be in the meter scale, but what we are doing, we are removing material at a micro or nano scale. That means our depth of cut is fraction of micron, or sometimes not exceeding more than 10 micron. So, this process is different than the conventional micromachining operation, but still it is considered as a micromachining operation or the process, because it is still a turning process. So, we will see some of the examples and how this process is different than the conventional turning process. So, let us continue our topic discussion on diamond turning. So, for this particular topic you can have these two different books and recently published. So, you will get most of the latest technology trends and theory and all the practices, mechanism about the diamond turning processes. And there are many book chapters available, many things I have covered from the book chapters, and research papers are also available for more discussion about this particular process. Now, we have discussed this thing a long time before when we discuss about the introduction section. Now, this graph I am again putting here, because this will tell you that where this diamond turning or the ultra precision manufacturing is sitting in a graph of a objective size versus relative accuracy. Now, if you see whatever we have discussed till now, micromachining is here at this location, because now if you see that it has a relative accuracy, that is very important, and part size is here at this location. It is in a tenths of millimeter to the few hundreds of micron. And if you see that its relative accuracy means it is a feature tolerance, that what is the tolerance of your component divided by object size. Now, this is what we have discussed. What we are going to discuss is this one, that is ultra precision manufacturing, where we can you can see the part size may be in terms of the meters, and what we are talking about the relative accuracy, it is much better than the other processes in this nano electromechanical system, micro electromechanical system, or our micromachining operation. So, here that is very important. Why it is very low in the relative accuracy? Because low in the sense the high accuracy, because smaller the value, higher is the accuracy, because our part size is very big here in the meter scale, and what tolerance we are making, it is in nanometer scale or the angstrom scale. So, that is the reason that you will get a very high relative accuracy in the conventional machining process. And let us see how these two processes are different. So, these are the differences between this, whatever we have discussed, micro cutting by mechanical method, and this is the ultra precision machining processes. Now, you can see the processes what we have discussed till now. We have discussed the milling operation there, then we have discussed the drilling operation, grinding also little bit we have discussed by for fabrication of micro cutting tools, and here what processes they use, mostly it is a diamond turning operation and fly cutting. We will see this both the processes, how these processes are useful. Tooling, we have seen that we can use many different type of tooling and coatings also, mostly it is a tungsten carbide, and then you do some type of coating to enhance the cutting tool life and the reducing the surface roughness and the wear of the burr formation of the components. And here what we are using only natural diamond tools, because we want to make sure that our tool should retain its specification, that means the rake angle and the other angles, so that you can actually get the defined features onto the workpiece surface. Component size, this is very important here, because if you see this component size what we have discussed here, that is here 1 to thousands of micron. and here it can be very large also. We will see some of the example where the size of the component is at the meter scale. Shapes, you can make any 3D shapes, that is the advantage of micro cutting by mechanical methods. Here you can also do many things here, rotational parts, spherical, aspherical surfaces, but mostly we get all these features in terms of turning operation. Absolute accuracy is less than 10 micron, but here it is very high, less than 1 micron, and relative accuracy obviously it is high, this is related to this part. Surface finish you can very easily get less than 20 nanometer. 20 nanometer is also high, you many times you will get less than 1 nanometer of surface finish on the different optical components. Machine, we use here the ultra precision turning machines for fabrication of different features, but here there are, we have seen that bigger size machines are available, micro machines are also available. Depth of cut, what we are doing, the depth of cut is very small here. You can see 0.1 micron depth of cut also you can give depending on the precision and the resolution of your machine. And application is mostly the optical materials, because we will see some many examples there that most of the components are optical in nature. That means, suppose you want to fabricate some lenses or mirrors, then you can go with a diamond turning operation. So, this diamond turning or ultra precision machining has a very large application area where you can get this thing done very quickly compared to other processes which are also available in the market. So, let us see further on this topic. Right. So, why we need diamond turning? That is the first thing, because if you see the alloy semiconductor crystals with very high level of surface quality are used as a mirror for different applications, mirror and lenses, astronomical telescope mirror, solar panel, satellite, navigation, night vision cameras, even whatever mobile camera also has lot of lenses available. So, all these lenses require very high level of surface finish quality. That means, you need a form accuracy also very high, and the surface finish should be extremely high in the cases. So, at that time you need some process which will give this type of requirement on a optical component. So, if you see these different type of crystals available, these are mostly used to transfer or transmit the light from one location to another location. Some of the mirrors are there, that will lights will be reflected and then you can get focused at different location, and these are the some of the telescopic mirrors, so that you can get the required photographs or some type of images taken from the satellite, right. So, traditional finishing what fabrication process are, these are the CNC machining process by the random process like the lapping and polishing, because what we are doing here, that if you do not use diamond turning, then you need a two-step process. So, first one what we are doing here, that first you give a shape of that, suppose your shape is something like a concave type of this type of shape, then you have to make sure the shape you are reaching by CNC machining process, mostly you can use the normal CNC machine. And once your shape conformation is over, then you have to look at the surface roughness. Then for finishing of this component, you have many processes available. Depending on the size, shape and the properties of this material, you can select lapping process or different polishing process, so that you can actually take care about surface finish or the surface roughness. So, it is a two-step process, but here diamond turning what it is doing, that it will do both the things. It will do shape correction also and it will do surface polishing also. So, in a single step you will get advantage of both the processes. Right. So, if you use that CNC machining and the polishing part, machining you can actually quickly do, because mostly it will not take much time depending on the size of the component and the shape of the component. But for polishing what we are doing, that we have to reach to a angstrom level or the sub nanometer level surface finish. So, at that time you have to spend more time and you have to make sure that there is no further damage to the surface, because our objective first is to remove the turning marks or the machining marks, and then you reach to the required level of surface accuracy. So, that is the reason that it takes lot of time here, the high cycle time is required, because process is very slow, because we do not want to damage the surface. Difficult to finish ductile material, because when you finish ductile material, chip formation is very difficult because of this ductile nature. It will actually do mostly the plowing things instead of a shear cutting. So, copper, aluminum, nickel, these materials are very difficult to polish by this type of finishing processes. So, diamond turning machining process has overcome these constraints for ultra high precision machining of components from engineering materials, semiconductor and crystals. So, mostly if you see any non ferrous material and which has some connection with the optical applications or some type of where you are talking about the light transmission and everything, at that time mostly it is understood that mostly it will be processed through the diamond turning operation. So, what are the applications of diamond turning? So, if you see most of the lenses are fabricated by the DTM. So, this is one of the application where polymer is being machined on a diamond turning operation, and most of the metals non ferrous mostly, because when you are using a diamond as a cutting tool, ferrous materials create problem for because of the carbon migration from the workpiece to the tool, and because of that you will get the different type of wear on the diamond cutting tool very quickly compared to the non ferrous material. So, copper, aluminum, brass and different type of silicon is also one of the materials, and all these materials can be polished, and you can see the surface finish, it is extremely high. You will quickly achieve less than 1 nanometer surface finish by setting optimum process parameter for the speed, feed and depth of cut. Now, these are the different things, and now if you see what are the different domains. So, there are different type of optical material, metallic optical materials available and the transmittive optics are also there. If you see material copper, aluminum, aluminum plate, electroless, nickel, brass. So, these materials can be processed by diamond turning operation, and this is the fly cutting. So, we will see that fly cutting, what is fly cutting. So, these are the different shapes you can actually fabricate by diamond turning operation on this metallic surface. And if you use a 2 axis of free form, so this is a turning operation and this is a fly cutting operation. So, here you can get the spherical, parabolic, hyperbolic, elliptical, aspheric. So, objective of this thing or showing this slide is to you can see the different variety of shapes you can fabricate by a diamond turning operation. So, it is not purely a turning operation, but you have a freedom to move your z axis, x axis and c axis independently from each other and in synchronize also, so that you can get the required feature produced on a different surface. Optics material mostly the germanium, silicon, acrylic, PMMA is also one of the material. So, in this case also you can create a lot of different shapes by using two different setup, by one is the by fly cutting and another is our conventional 2 axis machine, that is x and z axis, and another is the free form where you need a additional c axis or the additional z axis, so that you can move to get different optic free form surfaces. So, let me show you some of the videos here, because that will give you more idea that how these things works. Now, this is the acrylic dome machining. So, this is right now is the shape. So, we have to cut this thing in such a way that you can get very fine polished surface on the top. This is the tool post and diamond cutting tool was on the other side, and this is the one type of mist cooling or coolant or something which will make sure that the component is not flooded by the cutting tool, as well as it is removing chip from the surface very quickly. Now, you can see this is the surface which you can get by diamond turning. And you can see the reflection of different machine component here. This is the bellow on the carriage probably, and you can see that how this thing is being machined. So, this is the one example. Now, if you see bigger size component, now you can see this size is at meter scale, and these particular mirrors are mostly the aluminum mirror, where you want to get some type of application on telescopic things. And this is the diamond single point diamond cutting tool, and this is the removal of this part. and this is for concave mirror, similar to earlier application. Here also size is very large, and you can see these are the chips whatever is coming. So, you can see that it is almost a fine features. So, your machining requirement is very less in this case. And this is called the off axis mirror. Now, you can see that you have a synchronize between the rotational motion with respect to the movement in the z axis. So, these are called the servo mechanisms, fast tool servo and the slow tool servo. We will discuss this thing in detail. And suppose you want to make something different. So, here what it is doing, that here this is fixed and your this axis is working, z axis is working in a synchronized manner. So, it is the tool is now rotating and you are making different type of lenses on the surface. So, this is the lens mold. So, and after that you can actually create hundreds of mold here on a very optical grade surface, and then you do some type of polymer molding and you can get the required mold in a mass production. So, this is called raster cutting, raster fly cutting. So, what is happening in the fly cutting? So, here what we are doing, that our cutting tool is located on the spindle side, and it is a single point cutting, your workpiece is located at the bottom, and then you rotate the workpiece here in its own axis, and then you rotate your cutting tool in this direction, so that it do the machining operation. It is not visible here because it is rotating at a very high RPM. Now, let me show you, this is the bigger conventional example. Now, you can see this is the workpiece and this is the cutting tool. So, it is a single point cutting tool, but it attached with the spindle axis of the machine, and then it rotates. When it rotates, it has only single cutting edge which will remove the material. So, to get this thing done, you have to rotate this thing as a high RPM and a very low feed rate. So, you will not get any type of mark on the top surface. Now, you can see that it is rotating, and now you can give feed rate onto the workpiece. So, now it is removing the material. So, what is advantage of this thing, that here what happens, that you can actually do material removal on a very large surface, depending on what is the working area of this particular fly cutting tool. If it is a larger, that means you can get the even tens of centimeter of workpiece cut in a single pass. No need to do a multiple pass for machining of those components. And another thing, that this is the curvature. Now, if you see that you put this particular cutting tool on a horizontal axis, then whatever is this curvature, you can create a concave surface on a any circular component or the non-circular component. So, that is another advantage, because if you want to create a concave surface by a 3 axis milling machine, then you have to give a very small amount of x, y and z axis simultaneously, and that will create lot of problem at the later stage, because now it will this micro movement of in x, y and z direction, that will create some problem at the different type of tool marks. So, you have to remove those tool marks at the later stage, but here what happened, that we are actually using the circular motion. That means, whatever is the radius of this particular cutter, the same radius of concave surface you can create on a surface on any workpiece or optical material without any problem. So, this is the conventional machine, but same thing is happening on a diamond cutting tool also. Remaining this fast tool servo, slow tool servo, we will see when it comes. So, these are the different applications of diamond turning operation or diamond turning machining. So, we can see that their applications are very large in terms of processing of metal components, polymer components, and there are many different type of shapes also you can produce by this process. Now, what is the refraction? Because we can get two different type of things. One is you can fabricate lens also, and you can fabricate mirrors also. Now, if you see what is the application of lens, that this is the one lens here, and when light is passing through it, then it will focus at one location. So, that is called refracted of the light. When light is passing through the object, then it will actually bend, and after bending it will actually coincide at one location depending on how many rays are coming from the left direction. So, you need a focus point here. So, refraction is the bending of light as it passes into the other material of a different density. So, now the air density is different, workpiece this material refractive index is different, and then you are getting the light focus. Now, what is important here in this location? So, your important thing is then how this thing works. So, our objective is to get this focus point, right. Now, what happens that if there are roughnesses here, that suppose this is not completely polished with a high degree of surface finish, and other thing that its shape is not this type of shape. Suppose there is some variation in the shape, suppose shape is something like this, it is not exactly concave or convex on the other side. Then what happens that this particular ray will go here, this ray will go here, there is another ray which is coming from here, it will go here, and similarly this way and this way, like this way. So, you will not get a focus point, that means all rays whichever light whatever is coming from left direction to the right direction, they will not actually converge to one location, or they will not cross at a one location. So, that is the big problem here. So, if you do not get the shape accuracy and the surface accuracy very fine, then you will get this focus point at a different location. So, light is not converging to the one single point, and because of that you will lose intensity, you will lose the surface accuracy also here. That means, whatever things you want to transfer from here to here, instead of a circular point you will get an oval point, or you will get some other shape. So, at that time you are losing many features of the light. So, that is the why you require very high surface finish and the shape accuracy on a lens. Another thing is the mirror, because here what we are doing in lens we are transmitting light from through the surface, but here what we are doing, we are reflecting the light. So, here what happens, the light is coming parallelly in this direction, and depending on the concaveness of this particular mirror, you will get focus point at a different location, right. So, what is the reflection? Reflection is the change in the direction of light as it bounces off other material like mirror. So, mirror also you need a very high finish. So, similar to what we have discussed here, now if there is a roughness here and the shape is not exactly concave, that means there is no figure accuracy, then this ray will come here, this ray will go here at this location, another ray which is coming here, it will go here, this ray will go here. So, you will not get this particular focus point, and that focus point is important, because sometimes you want to concentrate your whole energy to one location to get things done. There are different material science applications available and different type of microscopic imaging available applications, where you want to focus the light at a one location only. Smaller is the focal point, more is the important things you can discover from that material research applications. So, these are the two different applications. Most of the times we go with the lenses and mirror by processing through the diamond turning operation. Like what are the different classification of diamond turning? So, there are two, one is the number of axes, 2 axes, 3 axes and the 5 axes. So, here this 2 axis, that means we are talking about the normal turning operation. Whenever we are talking about turning operation, this is the x and z axis only. So, here 3 axis, that means one of these axes will move independently. So, mostly it is a x, z and c axis, because we want to control the movement around the z axis. And if you want to add one more axis, then what you can do, that you can give the tilting of the x axis also. So, this is your cutting tool, then you give a tilting of this particular cutting tool in this direction, theta with respect to that. This is the z, this is your workpiece, then workpiece can also move in this direction, that is called the x direction, and rotation is obviously there. So, in that way you can actually give more freedom or the more flexibility to the movement of the workpiece or approach to the cutting tool. Another is the in terms of coordinate system. If you consider the x and z, then it is a normal turning operation, where we generally give a programming to the x and z. That means, in x direction you give a depth of cut, and then in z direction you give a Z direction you give depth of current, then x direction you can give a movement, that is when you do phasing operation. R theta means here what we are doing, we are not actually working with a Cartesian coordinate, but we are actually working with a polar coordinate. So, suppose you want to create some type of concave surface or convex surface, this type, and your cutting tool is here at this location, then what you can do, you can actually do machining by means of R and theta system. Then type of machining is a phasing operation and the flying operation. So, this is what we are doing, a phasing operation. If you see diamond turning, most of the lenses what we want to create, we want to create features on a flat surface only. Now, if you see, we have seen there are a lot of application. Suppose this is the component where we want to create some type of surface. So, what we do, suppose you want some lenses, then what we do, we do cutting something like this, correct. And suppose you want concave surface, then in one surface we do something like this, right. So, our most of the applications are actually focused to the phasing operation. Turning operation is what is that, suppose this is your workpiece and you want to turn this surface, that means our objective is to get features on this surface, not to this surface. So, at that time we do, but those applications are very limited, because suppose sometimes what happens that you want to create some features here and you want to, suppose you are creating some features here, that is the one of the application where you can do some type of mass molding of a polymer material or polymer sheet. Suppose here you have some type of features created, something like this, and all the surfaces, and then what you do, that you create take this particular wheel here. So, this is that wheel, and these are the features what we have created on the surface, and there is a polymer sheet which is coming in this. So, you rotate this particular part and then you move this polymer sheet through it. So, what we are getting, that we are getting all this feature transfer onto the polymer sheet, and then there are different application for different application of a polymer material with a textured surface. So, this is one of the application, and there are other 2-3 applications are also there, where you want to create some type of lenses with a circular patterns. You create those patterns on a cylinder and then you actually do a molding of the polymer material or some other materials. By that way you can do machining on a as a turning operation, but most of the application, 90% or more than 90% applications are related to the phasing only. So, you can get a different features on the phasing surface, and that is why x and z and r theta comes into picture. And this is the fly cutting. So, now how is that these things are different? Now, you can see the cutting tool is located here on a tool post, but here cutting tool is located on a spindle size. Our workpiece is on the headstock, but our workpiece is now located on a tool post, that means on the base surface. So, when this particular thing rotates, at that time it will scoop out the material from the surface. So, this is our surface and this is our cutting tool. So, this is our cutting tool, it is rotating from this particular axis. So, when it is moving, at that time it will remove this much amount of material, right. So, if you want to create a concave surface, then you continue this thing down and you finally you get a concave surface out of it. And if you want to create some other features, then also you can get this thing done very quickly. So, let me finish this lecture here, because now many things we have to discuss further on a diamond turning operation. We will continue this topic further in the next class. Thank you very much.